Greetings everyone, welcome back to another lecture on organic chemistry. In organic chemistry, um, to help you pass your Cambridge AS and A2 exams. So let's get started with organic chemistry. Okay, so I'm going to be reading these notes to you and explaining where I think you need to explain. But if where I finish this lecture, please download the notes in the link below to help you so that you may have your own reading, which may solidify what I have done. So let's get started. So let's talk about alkanes. Alkanes, as they have the general formula CnH2n plus 2, right? In examples of alkanes are methane that we have here, ethane, and propane, right? They do not have a double bond and they are said to be what? Saturated. Okay, let's move down. Now let's move on to alkenes. Alkenes have a general formula CnH2n, right? They have a carbon to carbon double bond. And because of this double bond, they are said to be saturated, right? The bond is said to be unsaturated. It's unsaturated. Only alkanes are saturated, meaning to say you can't add more bonds to it. But alkenes are what? Unsaturated, right? They are unsaturated. Meaning to say you can add more bonds to this carbon-carbon double bond. Okay, so yeah, those are alkenes. I'm just showing you different organic compounds that you are supposed to be familiar with before I get started before I get into the details of the organic chemistry course. So arenes. So we have organic compounds that are called arenes or aromatic hydrocarbons. These are compounds of benzene and its derivatives. Okay, so this is benzene, right? I shall do a separate video on benzene to help you explain what benzene is. Okay, so benzene can also have the hydrogen atoms there, which are not being shown here in the here, and here, and the 6 hydrogen atoms. One of the hydrogen atom can be removed and replaced with an OH group here, and now it's no longer called benzene but phenol, a derivative of what? Of benzene. You can remove that hydrogen atom and replace it with an NH2 group of atoms to produce what is called phenylamine. Or you can add an SH3 group there. It's no longer benzene but methylbenzene. Or you can remove the hydrogen atom there, put in nitrite, right? A nitrite group of atoms, NO2, right? So that it becomes nitrobenzene. All these compounds have what is called an aromatic smell. Okay, let's move down. At the bottom here, I hope you can clearly see this. We're talking about halogenoalkanes. These are one hydrogen atom of an alkane is replaced by a halogen. So we have there I wrote CH3Cl, right? I also spoke of CH2, CH3, CH2Cl. Those are the type of hydrocarbons that we have. Now let's talk about halogenoarenes, right? Halogenoarenes, these are like we said, benzene here. Here's our benzene. I shall do a separate video on this one. Okay. Though not shown, there's hydrogen atom here, right? Here, 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 and here. The hydrogen atoms. So one of those hydrogen atoms can be replaced by halogen to form a halogenoarene. Okay. Okay. So in number one here we have chlorobenzene. This is chlorobenzene, right? Number two we have 1,2 dichlorobenzene. I'm also going to do a separate video teaching you guys how to name organic compounds. So I'm just, for the sake of time, that's why I did not have to do it here. It would take much of my time. Okay. Then the next one is a chloromethylbenzene. This is chloromethylbenzene. I'm going to teach you guys how to name each and every one of these compounds. Let's move on. Let's talk about alcohols. Okay. Alcohols can be classified into 3 groups: primary, secondary, and tertiary alcohols. What is also One thing that is also unique about alcohols is that they have a relationship with alkanes. We're saying alcohols are compounds in which a hydrogen atom, just one hydrogen atom of an alkane, is replaced by an OH group, right? So now let us talk about these different types of alcohols. In a primary alcohol, right? In a primary alcohol has two hydrogen atoms, right? A primary alcohol has two hydrogen atoms, that is one other group, attached to the same carbon atom to which the hydroxyl OH functional group is attached. Now let me explain something there. Let me show you what I mean by that. So let's say this is my alcohol, right? I have my hydrogen there, I have my hydrogen there, right? You see, this OH group that I drew here is attached to a carbon atom with two hydrogen atoms here and here. This is a primary alcohol, right? This bond here can be an ara group, is what I'm referring to as an ara group. Now, in secondary alcohols, the carbon atom of the double bond is attached to one hydrogen atom and two other groups like this. And if it becomes a tertiary alcohols, it has only three other groups, and this carbon atom of the double bond is not attached to any hydrogen atoms. I hope I've made myself clear. You just have to know this, okay? A secondary alcohol has one hydrogen atom, that is two other groups attached to the same carbon atom to which a hydroxyl functional group is attached. So that's what I just meant to say there. So there's a point I need to make clear here. This one. Another group can be represented by the following. We've got what is called a methyl, right? An ethyl group, a propyl group of atoms, a butyl group of atoms. These are alkanes whereby one hydrogen atom has just been removed. Okay, this was once methane. We removed one hydrogen atom and it became a methyl group. This was ethene. This was the ethane. One hydrogen atom removed gives us an ethyl. Propane. One hydrogen atom removed, propyl. Okay, this was butane. One hydrogen atom removed is now a butyl. Okay. So here I was just giving examples of a primary alcohols, right? A primary alcohol here, ethanol, where it is an ethyl group attached to an OH group. That gives me what? Ethanol. It's an example of a primary alcohol. Here I have this alcohol that is here, which which I call to be secondary. It's butane 2O. Apologies for that, guys. I said I will teach you how to name this compound, but what I just wanted to illustrate for you, it has two other groups. This one other group, second other group, in one hydrogen atom attached to the carbon atom here, to which a hydroxy group is attached, right? And the tertiary alcohol that I gave you there, 3-methyl hexane 3O. Don't worry about the name, but what I wanted to illustrate there is this carbon atom attached to the OH group is got 1, 2, 3 other groups attached to the carbon atom to which a hydroxy group is attached. Okay, now let us move on to phenols. One hydrogen atom of a benzene ring is replaced by the hydroxy OH functional group. I think we've spoken about this, right? And aromatic compounds. Okay, this was just an example of a phenol 1.4 diphenol, right? 1.4 diphenol. Now the next group of organic compounds, we have what are called carbonyl compounds. Carbonyl compounds are recognized by their carbon to oxygen double bond and two other groups extending out, right? Now, these carbonyl compounds are divided into two groups. The first one is aldehydes, the second one ketones. In the aldehydes now, as you can see, let me use a different marker, different color here. How's green? Yes, green is okay. In the aldehydes, one of the other groups here is a hydrogen atom that you can see here. Okay, if you've got a carbonyl atom, whereby one of the other groups is a hydrogen atom, that becomes an aldehyde, right? So let me go read out something to you that you need to know about aldehydes. If you are going to write Blue's better. If you're going to write this in a condensed form, you write it as CHO, right? Not as COH. Because it begins to, because it looks like an alcohol, okay? So you always have to write in aldehyde as CHO, okay? And when you're naming in aldehydes, the names end with "al." For example, for this one, it's ethanol, propanol, methanol, okay? Now let's move on to ketones. A ketone, it's a carbonyl compound as well, like this. But this, it has two other groups. There's two other groups. And the other group is in no way a hydrogen what atom. Ketones contain a carbon-oxygen double bond, just like aldehydes, but this time in the middle of a carbon chain. But this time in the middle of a what? Of a carbon chain. There isn't any hydrogen atom attached to the group as there is in aldehydes. A typical example is this one. It's propanone. And ketones are shown by the ending of their name on the ending of their name with on. So we've it always begins with propanone, butanone, and so forth. It always ends what with on, on, O-N-E. Right? Now let us move on to carboxylic acids. Carboxylic acids, you should know this from your O level, I'm sure. These are just organic compounds with this kind of functional group that I have shown there. And I just gave an illustration of a carboxylic acid here. I'm going to teach you how to name this. I just want you to know the functional groups. That's all. If you follow what I'm doing here, guys, I promise you, I will make a point. You'll be the better for it. Just follow me through, okay? Now let's move on to esters. Esters are just compounds that are formed when alcohols react with carboxylic acids, right? To form this ester. This is the ester. An ester is identified by a functional group of the following, like this. I think this R there, then R there. This is the functional group for esters. So this other group that you are seeing here is the CH3 group, and this one is the ethyl group that is here and here. That's the functional group. This is the structure that represents what? Esters. Now let us move on to acyl chlorides. Acyl chlorides are just carboxylic acids whereby one OH group here has been replaced with a chlorine atom. Okay, that's what there is to it. And acyl chlorides, you should know this, these are the most reactive organic compounds. The most reactive organic compounds, yes. Now amines. What are amines? Amines, these are organic compounds whereby one hydrogen atom of an alkane has been replaced by an NH2. That's all. So this is how you represent an amine. That's all. Okay. And there's also nitriles, organic compounds that are called nitriles, whereby one hydrogen atom of an alkane as well is replaced with a CN group of atoms, right? So here, there's a mistake here. It's ethane nitrile. This is ethane. Let me write the name here, ethane nitrile. So the name does not mean is not propionitrile. So when you're reading this note, just make sure, guys, you get that fixed. Okay, it's ethane nitrile. In amides, let's move on to another group of. There are a lot of. We're almost through, guys. Don't lose heart. Amides. These are compounds whereby an OH group in carboxylic acid has been replaced by an NH2 group of atoms, and this is how you always name you always name the name for this one is called, for example, it is 1, 2 carbon atoms. It's we call it ethane amide. Ethane amide. Okay. The next group of organic compounds that you're supposed to be aware is these amino acids. This structure here is the structure that represents all amino acids. They have a carboxylic acid functional group there, and they have an amine side here. This is how you draw any carboxylic acid, any amino acid. Amino acids only define that they have different values for what? For R here. That's all. Now, let's talk about functional group. The functional group, as you know from your O level, it is the reactive part of an organic compounds. For alcohols, the functional group is OH, right? For alkenes, it's a carbon double bond. For for amides, for amides, this is their functional group. For amines, is NH2. For carboxylic acid, is their structure. Okay. For phenols, this everything here is their functional group. Okay. For esters, I've been drawing the structures before. I hope you were able to point that out, to pick that up. Okay. The structure of S that represents esters, that is their functional group, right? Pick up a wrong color, a different color here. For nitriles, the CN group is their functional group. For aldehydes, the functional group there that I want to draw is this one. This is their functional group. Okay. And for ketones, there are two other groups attached to a C2O double bond, right? And acyl chlorides. So what I just wanted to point out there to you guys is to understand that a functional group is the reactive part of an organic compound. Okay, that's all there is to it. Let's move on to processes. There's this same this new. Let's move on to the new subheading called homolytic fission. Homolytic fission is just a concept that we use for the breaking down of it's usually a halogen molecule, right? The halogen molecule breaks this covalent bond. That's all to produce radicals. We say homo means one, so there's an even distribution of the bonding electrons. This one receives this electron, or each of the electron it was sharing, and then also receives its own. It's an equal breaking of what? You can liken this to a, let's say, a couple. They divorce, then they share everything equally, something like that. Okay. Then there's the heterolytic fission here. When heterolytic fission takes place, there is an uneven distribution of electrons, of the bond electrons. So let's say this one here is deprived of electrons. It is deprived of electrons. In such a way, it becomes negative. It becomes positively charged here. Okay, and this one takes all the electrons of the bond, and it becomes what? Negatively charged. Okay, that's all. Don't forget to know the charges, right? Why am I talking about this? Why am I talking about these processes, right? Because we shall be employing the terminology in higher concepts in the next lectures. You will see this information helpful. Okay, I don't want you guys to be caught unaware. Okay, now let us move on to the next subheading, a nucleophile. Nucleo is from the word nuclear, and phile is it's a word, I think it's a Latin or Greek word, which means loving or seeking. So it means nuclear loving or seeking. These are usually negatively charged species, but some are neutral species. Okay, and examples of these species are these. Okay, they're always seeking for positively charged species. In electron loving, these are electron loving species. They have a positive charge, or they may be neutral. Examples of electrophiles are this, and that. So take down the examples that I was giving you of. There are many nucleophiles and electrophiles, but the ones that I've given as examples, because I've done an audit of this exam paper all the way from the 1970s. These are the most commonly asked to this point. Nothing is changed. Okay, so follow me through if you want to make it. So let's move on to another type of reactions, addition reactions. Addition reactions are only happen in what? In saturated bonds. For example, usually alkenes, right? We're adding a bromine atom there to form what? It is an alkane whereby one of the hydrogen or atoms are what? Halogens. Okay, we call these halogenoalkanes, but I'm going to talk about this in more detail in the next video. So this is what this type of reaction is called an electrophilic what? Addition reaction. It's an electrophilic what? Addition reaction. There's something else there. An electrophilic addition reaction. I think I did not leave anything behind. Okay. Now I want to talk about substitution reactions. These are reactions in which an atom or a group of atoms is replaced by another atom or a group of atoms in a compound. So in this course, you're going to come across what are called electrophilic substitution reactions, nucleophilic substitution reactions, depending on the species attacking. Okay, I just want you to know that this exists, right? The next type of reactions that you're going to come across in organic chemistry, um, elimination reactions. These are reactions in which an atom or a group of atoms are removed from a compound without replacing them. I just wanted you to know that. Okay? And hydrolysis is the breaking. Let's move on to the next topic, hydrolysis here. Very, very important. We're breaking a compound by adding H2O. Hydro means water, lysis means breaking. That's all. So sometimes it can either be acid hydrolysis or base hydrolysis, depending on the situation as well. Okay? So under acid hydrolysis is breaking a compound into its constituents, right, by adding heat and dilute acid. Now, in base hydrolysis, we're breaking down a compound into its constituents by heating in the presence of a base. That's all. Let's move on to isomerism. Isomerism. This is the existence of compounds with the same formula, molecular formula, same molecular formula, but different structures. Okay. I'm also going to do a separate video on isomerism, but not now. Because I'm trying to cover as much ground as possible so that you guys are able at least to answer the exam first. Then those additional videos that I'm going to make will only be building up on the foundations that I'm building on. Many people who have followed my method have succeeded tremendously, and not one has ever failed. Okay, just follow through what I'm doing. Now, isostructure. Now, there are different types of isomerism. Okay, different types of isomerism that you can come across. With the one which is called structural isomerism. What are we saying? Look at these structures. This one is chain isomerism that we have here. Under structural isomerism, we've got this molecule, and this molecule, and this molecule. They have the same formula, the same number of carbon atoms, same number of hydrogen atoms, right? But how these atoms are arranged is different. That is what we're referring to as what? As isomerism. I shall make a separate video on isomerism to help you understand this, okay? Now there's one called the second one. We need to also talk about positional isomerism. Okay, the position that we're talking about there is the position of the functional group. Let's talk about the alcohols. It's the same like these compounds that are here, guys. They have the same number of carbon atoms, hydrogen atoms, and oxygen atoms, right? But the OH group here is carbon atom number 2. This OH group here is carbon atom number 3. This one number 2. And this one is carbon atom number 1. This makes the compounds different altogether. This shall be consolidated when I shall be talking about what? Naming and isomerism. You will see why these are actually different compounds. They have the same number of carbon atoms, same number of hydrogen atoms, and same number of oxygen atoms, but different compounds. That's what we mean by isomerism. This one called ketotautomerism is not really important, guys. It's not important. Let's keep it. Okay. Let's talk about stereoisomerism. Stereoisomerism is divided into one geometric isomerism and optical isomerism. Let's go on to geometric isomerism. So, geometric isomerism is what is known as cis and trans forms, or cis or trans isomerism. In the cis means same side, a trans means opposite side. Let us look at this CH3 group of atoms here. They're on the same side, right? They're on the same side. That's why it's a cis. It is cis. They're on the same side but attached to two different atoms of the double bond, of the carbon to carbon double bond, and they're on the same side. This is what makes them cis. And here, let's look at this CH3 group and this CH3 group. Okay, they're on the opposite. They are on the opposite. They are on the opposite sides and attached to two different atoms of what? of the double bond, of the carbon to carbon double bond, and that's what makes them what? Trans isomers. You're also supposed to be aware that this group of atoms, these ones, can also be, all four of them can be different, right? So you also need you need to describe it in terms of molecular mass. I'm going to also explain that. Okay. Now let's say we've got this molecule here whereby we have the hydrogen atoms attached to the carbon atom of the double bond, and CH3 atoms attached to the carbon atom of the double bond. The double bond restricts rotation, and so therefore, since the double bond restricts rotation in this molecule, we say this is not a geometrical isomer because the carbon-to-carbon double bond must not have similar group of atoms. That's all. We're done with geometrical isomerism. Let's move on to optical isomerism. Optical isomerism, or optical isomers, are also called enantiomers. Okay, they are called enantiomers. It is a type of let me read out the notes to you. Okay, is the occurrence of compounds with the same structural formula but different spatial arrangement of atoms. These isomers are asymmetrical or chiral without a plane of symmetry. I'll explain that. Look, this example of a molecule. It is chiral in such a way that this carbon atom here, which is said to have in asterisk, cannot be from this carbon atom which is in the middle. You can break it into equal parts, right? It is attached to 4 different group of atoms. Let me read. That's why we're saying it's asymmetrical, right? Or chiral. Chiral, I just mean to say this carbon atom here is attached to 4 different group of atoms. This one, this one, this one, and this one. They are non-superimposable mirror images of one another. They have the same physical and chemical properties, and they rotate plane polarized light in equal but opposite directions. So there are similarities to these optical isomers. They have the same physical properties, they have the same chemical properties. Their only difference is that they rotate plane polarized light in equal but opposite directions. Okay? So a typical example of an amino acid here. We have in amino acids. Amino acids are typical examples of optical isomers. Well, we say they're mirror images of each other. So let's say you've got optical isomer A and optical isomer B. If you know from your mathematics, they produce a mirror image like this, right? So this COOH group was just reflected here, and this reflected that side, and you reflect this one to this side, and this structure, guys, is a tetrahedral. It's tetrahedral. It assumes a tetrahedral shape. Okay. I think that's what you need to know about optical isomers, guys. So thank you for joining me in this video for the introduction to organic chemistry. So this video was designed for you guys to grasp as much content as possible in the first reading, so that you are almost able to understand most of the technicalities and the terminologies that are used, the technical language that we shall be using in organic chemistry. Thank you guys for watching the video all the way to the end. Please, if you have any other questions in other videos you would want me to make on this topic, please write down in the comment section. And if you like this video, please comment, like, and subscribe, and I'll see you all next time. Thank you.